For my course project, I did option B, project 4, wireless sensor network for data collection to cloud using 4 Raspberry Pis. Each Raspberry Pi node connects with an HCSR04 ultrasonic sensor, acquires its data in centimeters, and sends it to the Google Cloud for visualization. Here you can see the circuit for each Raspberry Pi and ultrasonic sensor implemented on one breadboard. A 5-volt pin from the Raspberry Pi is connected to the VCC pin on the ultrasonic sensor. A ground pin on the Raspberry Pi is connected to the ground pin on the ultrasonic sensor. The GPIO 23 pin is connected to the trig output pin on the ultrasonic sensor. And finally, the GPIO 24 pin is linked between a 1 kilo ohm resistor and the echo input pin on the ultrasonic sensor with a 2 kilo ohm resistor and ground. This was necessary to allow for a voltage divider to reduce the voltage of the echo input from 5 volts to 3.3 volts. Next, I created a Python script to read the data from the sensor, convert it to distance, and insert it into the Google Cloud MySQL database. I first declared the corresponding GPIO pins with trig and echo from the ultrasonic sensor, and then created methods I would later use to read and insert into the database using SQL commands. In main, I created a loop to read the data, convert it, and utilize the database methods. I found the duration of time from the difference in the time a pulse from the ultrasonic sensor was sent out and the time the pulse had returned. I used the speed of sound at 343 meters per second to then finally calculate the distance. I also had to account for the time being twice the amount to take to get to the object because the pulse of the ultrasonic sensor needed to return. I then printed the result from the sensor distance data as well as the inserts and readings from the database to the console for testing. First though, I needed to create a database to use with my script file. I tested it with a local database so I could access it through a web-based PHP admin server. Then I just needed to transfer it over to Google Cloud. So I created my instance and database in the Google Cloud platform. The database table and values can be seen here, where the rows for the table were just that of the sensor data value and the current timestamp of the data being inserted. I kept everything the same as my local database and only needed to change the host to the external IP address of my Google Cloud instance. I also needed to authorize my public IP address in the Google Cloud instance. Then I configured my Raspberry Pi network using an open source web interface called RasAP to control Wi-Fi, IP addresses, and ultimately my hotspot network that I would later connect my other Raspberry Pis to. Next, I copied the micro SD card from the sync node to the other Raspberry Pi micro SD cards in Windows Disk Imager and changed their IP addresses in RasAP so that they were not the same. Finally, from Google Cloud Studios, I visualized the data, which included all values stored in the database here. For a better form of visualization, I then created a virtual machine instance in Google Cloud Studios to show the data from the last 30 minutes in Grafana, which can be seen here. Again, I had to authorize the external IP address of the virtual machine instance in my Google Cloud instance and then add the Google Cloud instance IP to connect the data source in Grafana. You can also see that there are a few instances of sensor data variation at a given point in one given time, but only by a few centimeters. Thank you.